Okay, I hope everyone can hear my voice, and let me start the course, and I will announce several informations. First of all, we will have online course until May 3rd. Okay, so our midterm will be on May 4th. Okay, and our schedule. So because today I'm preparing the questions for exercise. So for today's course, I will explain a little uh, chapter 12.5. Only a little bit. I forgot some points here, and then we can have exercise chapter 10, 11. Okay, and for Thursday, so for Thursday, uh, because if we are not continue the chapter, so I think we need to move to chapter 12.6 on Thursday, and maybe in the last 30 or 40 minutes, maybe exercise for midterm. But I think we can just focus on 12.6 first. Okay, if we have time, we can have exercise on Thursday. Okay, so I will go to 12.5 a little. Okay, so I forgot something in 12.5 to finish the chapter. And then after 12.5 finish, we can continue to exercise on chapter 10 and 11. Okay. Okay, I hope you don't mind for today's course, online course. Okay, so May 4th is the midterm. Okay. And also your I suppose supposed to be your TA supposed to be also online. Okay. Now let's start the course for 12.5. I will have some maybe a little break after a few sections. Okay, so you can uh, write down some notes if you want. So I will start with 12.5. This still in lines and planes. We will continue on. It's called the distance. So if we have P1, let's say it's on X, wait, let me write down in terms of X1 and Y1 and Z1. That's the point. Okay. So let's say we need to find distance from, let's say, P1 to plane to plane. I will write the equation plane. So ax plus by plus cz plus D equals 0. Okay. Remember that this is the equation of plane. Okay. And then we let some point, let's say P0. It's x0, y0, z0. This is any point in plane. Okay. In equation plane. Okay. And we have factor B, and we have factor B. It's the factor P0, P1. Okay. So B is P1 minus P0. So x1 minus x0, y1 minus y0, c1 minus c0. Let's say we have all these conditions. Okay. Okay, to make it more maybe clear in visuals, let me help you with some picture. Let's say this is the plane. Okay. And we have P0 maybe here, or maybe here. So P0, let's say this is the line for B is maybe here. Okay. Let's say this is vector B, and this is P1. This P1. So P1 is above the plane, and we have okay, a normal vector. And what we need to do is we need to calculate this distance. Okay. Okay, now based on the informations on this picture, maybe I will add also angle here, okay, to add the informations. So based on these informations, remember that we have relations from this D. Okay, let me. So this D, okay, and this angle we have a component. If you remember the formula, let me write D is component B on N. Okay. So this will be normal vector dot B defined by normal vector. So we calculate the dot product for N and B. And let N, let me write N here, let N is a vector with A, B, C as direction numbers. So remember, this is direction numbers. So A, B, C is direction numbers. So D will be N dot B. So A, B, C dot D factor B. So A will be multiplied with x1 minus x0 and plus B with y and plus C with z. And the magnitude for vector n will be a squared plus b squared plus c squared. Okay. And let's solve and simplify. Okay, we have this, and the same for the numerator. Okay, now because P0 is on the plane, the coordinates satisfy the equation of the plane. So we have which means our conclusions, distance d from P1 to the plane is okay. Now let me just take a couple minutes for you to think and maybe see the all the formula here. So this is the result. The formula for distance. Okay. So distance from a point to a plane. Okay. So distance from point D from this distance D from the point P1, sorry, to plane. So what you need to do is you need to make sure the plane, the form of the plane, ax plus by plus cz plus d, and then you need to use a, b, c onto the equations for distance. Okay. Now I will give you some example and some notes for some terms in line and plane. Okay, I hope you get the idea for the distance. Okay, let me give you the find distance between planes. Let me write the equations. 10x plus 2y minus 2z equal 5, and 5x plus y minus z equal 1. Okay, first we can see that the normal factors from both sides, from both planes, the first one is having 10, 2 minus 2. The normal factor for the second plane is 5, 1, negative 1. So both are, if you see, it's only having similar number of factors. So n1 is 2 and 2, right? So we can say that n1 is parallel with the n2. So the normal factors are similar, and we can say that this is parallel. So to find the distance, so to find distance, we choose any point on one plane, and calculate its distance to other plane. So if we put y equals z equals 0, we will get 10x is 5. So we have x is half. So we will have point half 0, 0. So this point is our P0. Actually, we set up the P0. So distance from and the second plane. So we can write down, or we can write down as equaling to 0, like that. So we can write down the distance having, this is A, B, C, D. Okay, so we can write down 5, and then the x0 is here, y0 is here, c0 is here. So 5 multiplied with half plus, that's all 0. So let me just write 0 because we multiply with 0, and then minus 1. And then divide by we add all the squared form. So we get that our distance. Okay. So first, to find the distance, you need to look for, or if the questions is, let me give you a guidance here. So if the question is asking distance between planes, okay. So the first plane is this, the second plane is this, okay. The first thing you need to look for is you need to choose any point on one plane. You can choose the first plane, the first equation, or second equations. So first, you can make it, for example, like I did, y and z, make it 0 so that you can find point of x. So this will be your p0. So with p0 here, we can use that to find a distance to the other plane. Okay, and this is what we got here. Okay. Okay. Another thing about this plane that parallel, okay, because of the parallel, let me draw some illustrations. For example, if this is our plane, uh, let's say this is also the plane. So you see that both our plane are parallel, and if we are drawing line here, maybe with here, and drawing line here, any line that you can draw here, you can see that because all lines in each plane are not intersecting the other plane. And for example, if to make it easy for you like that, if I have this plane A, line A, and line B, like here, then A and B is not intersecting, and in this case it's not parallel. We call this is a skew line. Okay. Okay, I think that's for the additional notes for 12.5. Okay, about the distance and some example for distance between planes. So I will continue to other lesson. Actually, I'm preparing for a review for your midterm. Okay. If there's no questions here, is there any questions? If no, then I will move to review for midterm. Okay. So again, the midterm will be next week. Okay, will be next week. Will be Tuesday next week. Okay. Okay. Let me move to the next slides. And I hope you can have some notes for you for exercise. Okay, I'll write down some questions. Okay, I will write down the questions. You can try to solve the questions first. So equations of tangent to curve at t equal pi/2 is, let me give you the options to make it more interesting. So let me write y Okay, that's the first question. Let me check the other question. Okay, number two, we have functions g, and the series should be converged. So when the series is converged, and we have options which of the following are true. If you see R like this, the answers can be more than one. A, the domain of G is 2 to 4. G is differentiable on 2, 4 open interval. G prime is square root of 2. And G double prime is square root of 2. Okay. Maybe giving you some time to check the answer and try to solve. Maybe 5 minutes around. Okay, 5 to 7 minutes. Try to check the answer. If you want, and maybe you have done, you can check the answer. Okay, if you solve and maybe find the answer, you can write. Let me write this is number 1. This is number 2. You can write the answer like maybe A, B, C, like number 1, A, number 1, C, number 1, blah, blah, blah. Or number 2, A, number 2, B, blah, blah, blah. So you can start to check the solutions if you want. If you just come now, don't worry. You can watch the video later on the recording. I will prepare the recording. And also, if you want to scan the QR code, you can do as well by the recording video. Okay. Okay, please, if you solve, write down the answers. Maybe the first question first. The first question. What's the answer for the first question? This one. Equation of tangent to curve. You have x and y. Number 1. Yeah, number 1 C. Correct. Yeah, before I giving you the final answer, is there anyone solve number 2? It's more than one answer. The options have 4, so it can be all true, or maybe only A B, or only A C, only, or A B C, or B C D. Okay. So you need to check number 2. And remember the concept. Okay, what's the difference on domain and what is differentiable means? Okay. Okay, let me go to the explanations for the first one. I think the first one is not too difficult. It's quite easy. You need to be careful for the calculus part. Okay. Let me write the here. So equation of tangent. Okay, everything about tangent is solving and find this dy over dx. Okay, whether it's in the parametric, Cartesians, everything about tangent is about dy over dx. So dy over dx in these terms, because we have parametric t, we will write down this definition, okay, because of the chain rule. And we can set up h for y and x. For example, if x is, let me write x and y prime. So this will be negative sine t plus, or in this case is minus. Okay, and also here is y prime, and this also become plus and plus. Okay, and we set up into our dy over dx here. So cosine t plus 2 cosine 2t and we are plugged in our t equal pi over 2. You see here pi over 2 here becomes 0, right? And this become negative, so negative 2. This becomes 0, this becomes negative 1, so it will be negative 2, negative 1, and then this will be 2. Okay, but since I gave you 4 options in which all is the equations, remember on the last quizzes, I gave you the similar similar questions with the equations on the front, but you are just answering until dy over dx, which is it's a half answer. Okay, so equation means you need to complete your solutions. So we need to use the dy over dx as our gradient. So y, let me just write the equations. So set up the t. So at t pi over 2, you need to check y and x, in which both are 1 and -1. So this will be 2x plus 3. Okay, that's number 1. Okay. Okay, I hope you get the idea correct. Okay. You need to be careful in the calculations. Don't forget that the equation y should be here, and this x should be at the numerator. Okay. Careful for calculations. Okay, number 2. We have function g is the series, a power series. Okay. And when the series is converged, which of the followings are true? So let's break down our g. So let's go here. So let's write the sum. Okay, this is the sum. D statement. Yeah, g. It's the second derivative, g double prime. Okay, so g double prime of 3 is square root of 2. Okay. So anyone solve number 2? What is the correct answer? Which of the following are true? Okay, let me continue to solve number 2. Okay. So number 2, we need to set up the series and check with the ratio test. It's convergence and interval convergence. So check. If you forget ratio test, this is what you need to do. Okay, and check the limit. And this will be canceled. So we have a limit and square root, and this our n, and this is x minus 3 with the absolute value. This will be 1, so this will be just x minus 3. So to be converged, this should be less than 1. So x minus 3, let's solve this. So it will be 2, 2, 4. Okay. But it's not complete yet for the interval. So we need to check x equal 2. So check to our equation here. Or let me write let me write here. So check x equal 2. So this series will become -1 and then square root of n. And this is the alternate series, right? And it's, remember, alternating series needs two components. First, it should be decreasing. And it's true that n, as our n increase, it's decreasing, right? And two, the limit of the an should be 0, which is also true. The limit of this is 0. That's true. So it's converged. It's converged by alternating series. Okay. So check the other x. Check x equal 4. Okay. So every time you are having interval from the ratio test, from this power series ratio test, don't forget to check each endpoint. Okay. Check x equal 2, check x equal 4. The sum now become 1 over square root of n, which is diverge, right? Which is from P series, the P equal less than 1, so it's diverge. So the interval of convergence is 2, 4, and 4 is not included. So let's check the options here. So domain of G is 2, 4, and closed interval. So this should be 2, and then 4, and then open interval. That's the meaning for domain in these options. Okay. And number B, G is differentiable on 2 to 4. Is it true? Okay, based on definitions on differentiable, remember the calculus 1, what we did on last semester. So since domain of G is this, then G should be, okay, should be differentiable on the open interval, right? So that's true. B is true. So B is true. Let's check the other options. G prime equal, so G prime, let's write G prime X. Okay. From our equations here, what G prime means is we are deriving this series. So we are putting here and -1, so become like that. So this is become n, and then x minus 3, and then n minus 1 divided by square root of n. And we are plug in 3, it's 1. Square root of 1, and it should be 1. So C is wrong. How about second derivative? So second derivative becomes n minus 1, and then x minus 3 minus 2. Okay. Divided by square root of n. So if we have 3 to be plugged in, so 2 2 minus 1. So it should be square root of 2. So it's square root of 2. So that's correct. So D is also true. So the answer for this one is B and D. Okay. Okay, any questions? Okay. So far, I think not too complicated. Okay. Okay, let's continue. Okay. Or do you want to see this first? Okay. Okay. Let's continue. Anyway, continue. Find area of the region close by let me give you options. That the first one. Let me check the other. Okay, let me give you this one. Number 2. Suppose you have 0. And this sum of B is convergent. Which of the following must be true? So again, this is more than one answer. And it's a little bit tricky. Okay, this is the question. So try to solve first. Maybe 5 minutes to solve. And let me solve for you after 5 minutes. Okay. So for today, I will give you some this exercise, and then the Thursday class we still have exercise, but we'll continue to chapter 12.6 first, okay? And then continue again the exercise for chapter 10 and 11. Okay, because I think we don't really have much time left for the other chapters. But if we are still not be able to finish all the chapters, maybe each sections I will maybe skip some parts. So I will do that if we don't have much time left later. Okay. So I hope you don't mind. Yeah, because today's class is and the announcement are just sudden announcement. I think from a few days ago, we need to make some prevention measure so that we have clear guidance for the COVID. Okay. Okay, for the first one, let me write the questions. Sorry, so the number is, this is 1, this is 2. So what is number 1 now? Find area of the region enclosed by the cardioid. And then the second one is supposed to be analytical questions. So the second question is actually asking it must be true. So in any cases, for any AN or BN, all these options should be true, and you need to choose which one. I think more than one. The answer is more than one. Okay, number 1. What is the answer? A, B, C, or D? Yeah, it's B. Correct. It's B. Okay, let me give you some calculations. Okay, so for number 1, if you want to draw this, okay, you can draw the cardioid. So this will be the cardioid. This should be 4. This should be 2. Okay. It should be also, you can write this. Okay. So this cardioid, first is to find the area. You can do that by evaluating from theta equals 0 until here, until theta equal pi, and then multiply by 2. Don't you ask how to obtain? Okay, let me go back a little bit. Okay, so G prime basically you just derive this series. Okay, derive the series from. Let me write here gx. Okay, so basically you need to derive from G. So it's the same thing as you derive with the other equations. Oh, don't forget to write the sum. I forgot to write. Sorry. Should be write the sum here. Okay, now I think this should be okay. So derive and becomes n minus 1, and then derive one more time, become here and n minus 2. And since it's shifting with this n minus 2, this should be equal to. Okay, so that if we plug in here, it will be 0. Okay, and now plug in 3 into the x and replacing x. So 3 going here minus 3 is 0, right? And also the same thing here, 3. And you get the results directly from the series. Okay. 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 Okay, let me continue here. So the area for the cardioid, it's twice of the area from here, 0 to pi, and half of this squared curve. And now you have these equations. And you need to rewrite this in terms of double angle formula. Okay. And write down all. Let me write this first. And integrate. and this will be 0, so it's 6 pi. So it's B. Okay, number 2. So let's see the restrictions is AN is less than BN, and both are positive, greater than 0. So since BN is convergent, okay, so which of the following must be true? So if BN is convergent, AN should be convergent, right? When we calculate, do we need to care about the square root of n below? Okay, let me check. Yeah, of course. This is actually, if you see the if you check the from the original equation, if you check x equal 3, it's all become 0, right? So in order to see the questions in a more clear way, you need to check the n. Okay, you need to check the n first. Okay? So the n, like for example, from G to G prime, the n is still the same, equal 1, because when you plug in 1, there's nothing wrong, right? So it starts from x minus 3, and then plus x minus 3 squared 2, and then so on and so forth. So plus 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 plus, right? And when you derive, when you plug in 1, also still okay. It's still okay. If you plug 1 into here, 1 minus 1 it's become 0. So all will be 1. Okay. Okay. So this part, the square root, is also we plug in 1 inside, right? The second derivative, because we are having this formula, we have n minus 2 here. Okay. Remember, in sum, in series, the n, it should be in positive. Okay, the result here. So if you plug in, for example, if you plug in 1 minus 2, it's become minus 1. It's become, how to say that? It's not in our domain of n. Okay, the n should be from it should be from 0, 1, 2, 3. It should be in a positive. Okay? So we are changing the n from n equal to. Okay. So we plug into all this n. So it's become 2, 2 minus n, like here, 2, 2 minus 1, and then the square root becomes square root of 2. Okay. And then actually this part, this x minus 3 part, because n minus 2 is already 0, so we can cancel all the x minus 3. Okay. So actually, g prime with this the number here is not too relevant, because when x is equal 3, it's actually making the series becoming 0 actually. But in terms of radius, in terms of convergences, okay, in terms of convergence, we are calculating the n first. So we get the results. The g prime is 1. G double prime is square root of 2. Okay, so we need to calculate n first. Okay, that's why we need to check all the n. Okay, it's like when you are evaluating limit, you have n and you have also x, right? What you need to do is you need to evaluate the n first. Okay. So it's actually not only 3, it can be in any number, because it will be resulting to 1, and the second derivative resulting to square root of 2. Okay. Okay. So back to number 2 here, this the second question. So a and bn is convergent, of course, right? So this is also true because it's less than bn, because an is less bn. So an should be convergent, right? The second one is also true because it's alternating series. So this also converge, right? Now, the C is quite tricky. So let me ask you: is this true? Is this true, or is this always true? Okay. For example, if I have bn is 1 over n squared, the square root of bn is 1 over n. This is converged, of course, right? The P series. But this is become diverged. Okay? Because P is now equal 1. No, this is not always true. So this is false. But here, because remember, an is less than bn, right? Because an is less than bn, whenever you have, like, for example, the bn is like 1 over n squared, this should be less than that. Maybe 1 over n cubed, or n4, n5. But the answer, it's also converge, because A is always less than B. So this is correct. So the answer should be A, B, and D. Okay. Let me give you another question. Maybe last, maybe I can add more, maybe 4 questions. So let me give you another questions, 2 questions. Which following series is divergent? Okay, that's the first one. The second one, if functions then f okay, 2 questions. Okay, so the first question is checking the series, whether it's diverged or not. The second question is actually about the Maclaurin. The Maclaurin, if you remember, the Maclaurin constant. This is the Maclaurin constant. Okay, let's start from number 1. Or do you have any solutions for number 1? Which following series is divergent? There is only one answer from 4 options. And the second question, if you have a functions x, e with power of x, then the f100 means the you derive 100 times. Okay, and when x0, so it's when x0 means it's a Maclaurin series. So Maclaurin series, you have from f from the first equations, and then the first derivative, second derivative, third derivative, until some n derivative, right? Let me maybe remind you the Maclaurin we have. Like that. And we can expand this into okay, and expand all the terms. Okay, and now you need to rewrite in terms of x e with e to the x. Okay, you can try that, but I will going to number 1 here. Anyone solve number 1? Which one is divergent? Okay, let me take some for each. Let's say from A, we have n divided by 2 with power of n. When you see this series, you can check with comparison test if you want, or you can just go to ratio test if you want. So if you go to ratio test, it will be n plus 1 and multiply with 2 and n. Okay, you get half, and this part is becoming 1, right? So you have the answer is just half. It's less than 1, so it's converged. Of course, it's converged. So number A is converged. Number B, you have the alternate series. If you check the alternate series, this series will be decreasing, and the limit of its sequence is 0. So it's converged also. And this is obviously it's converged because of the P series. The P is more than 1. The last part is quite tricky. You need to arrange into this form. So from here, arrange these equations into n minus square root of n divided by n squared of n. And we can simplify this into n divided by square root of n. It's become this. And this is, by the case, is greater than 1 over n. If you check from n equal 1, okay, 2, 3, and so on. And because this is diverged, right? P is equal 1, P series. So this whole thing is divergent. Okay. So the answer should be D. Okay, now we have number 2. The functions is e to the x. Okay. Now I remind you before how in Maclaurin we have a functions, and this is our general equations. Okay, we need to find only this part when n is equal 100. Okay, now please concentrate on this. Let me write e to the x in terms of sum, in terms of series. If you remember, this is our formula. Okay, now we multiply with x. Okay, and our formula becomes this having n plus 1. So the key is here. The key is it's having n plus 1 now. If I make this into k, for example, in general functions, let's change into k, where k is n plus 1. So when k is 100, so let me write here. So when k is 100, what's its equal with? Now you have n plus 1, right? So n is k minus 1. So n is 100 minus 1. It's 99, right? So you will have in terms of this equations, because this having n plus 1, imagine that you have 100 like that. And this part is having n plus 1, which is 99 here. So this, by that logic, this should be equal 99 factorial. So the terms of this constant is become this divided by this, which is only 100. And that's why the answer for the second question is B. Okay. Now I think we don't really have much time left for today. I will continue the exercise on Thursday. But before we continue, I will continue chapter 12, 12.6 a little bit, and then exercise. Okay. So we will have more details on Thursday. So if you have still have confusions, just let me know, or you can reach me through the Moodle and email. Okay. Okay. If there's no questions, then I will stop the class for today. Okay, any questions? Or you can type in if you need to ask anything. If no, you can watch the recording later on the Moodle. I will attach the link, and you can watch them. Okay, if there's no questions, then I will stop the class until here and see you next Thursday. We'll still have the online class. So Thursday, still online class, maybe 30 or 40 minutes at the beginning. I will go to 12.6 and then another exercise for chapter 10 and 11. Still, and please check the Moodle. I will also attach the Google Meet link on Moodle. Okay. Check Moodle because I think we will have different Google Meet link. I think that's all for today. So you can leave the Google Meet